This conference will now be recorded.
Good afternoon, students. Today we are going to discuss about dynamic response of a two-area low frequency control. So in last class we discussed the same thing about static response, and today we are going to discuss about dynamic response. And the main intention, so again I'm going to say that the main intention of this type of low frequency control means to getting a proper output and quality output from the generating station. So when it is obtained means when we can avoid that interruption happening in the power system, like power outage, like damage. So this are and all makes that interruption in power system. So when we avoid this type of interruption, then only we can maintain that proper output and quality output to the distribution, that is load side. And the main intention is so we need to be continuous supply to the load. So when it is obtained means by using that the combination of multiple generating stations. So in that case, if you want to adding that two different types of power stations as a one unit, we need to make that some arrangements. We need some requirement. We need some controlling action among the two stations. So that control action is nothing but a low frequency control. So when we applying this type of controlling mechanism, then the two power stations having different characteristics, even though then the working of the two stations should be same, then only the contribution of power should be sharing among the two stations will be very in good manner. So this type of algorithms and this type of methods we can use in load sharing, like power loss reduction. So this and all belongs to the low frequency control. And this is the major topic, and this is the most vital topic for doing the many projects on this BTech level. So it means that if you are considering the one network, in that network we are going to find the losses, and we are going to find the what is the system performance, and this type of methods, this type of knowledge we are getting by using that low frequency control. So there are different algorithms are there for using the low frequency control. So later we will discuss, if you have free time, we will discuss that what are the different types of algorithms are using for low frequency control. So generally the algorithm should be depends on the capacity of the system. So capacity in the sense what is the network capacity and what is the power capacity, how much, what are the load capacity. So this and all comes to that comes to the consideration while doing the algorithm control. Now let me move on to the topic, that is a dynamic response of two area low frequency control. This is so already we know that the certain conditions we are going to take for dynamic response, that is so in the dynamic response what are the consideration we have to choose means we have to choose that so in that it is belongs to the uncontrolled case. So already the entire power system was represents by the two parameters, one is load speed changer and the other one is load demand. So by using these two parameters, we can assign that whether it is uncontrollable and controllable. Now we are going to derive the derivation for dynamic response of uncontrolled case. Already we know that when the system is uncontrollable, when the load changing is not in our hand, then the system is called as uncontrollable. Now in this case, we are choosing that the speed changes occur in the area 1 and area 2 becomes 0. Then we can write when considering this delta, that speed change is 0 and the delta PD is variable in the system, and based on these two parameters we will bring that, we will make that transfer, we will make that equation from the block diagram for two area system is like this. So here delta, so how it will come obtain is, I will show you that the see here, this is the equation we can obtain from the by using area 1. So this is the area 1. So already we have the time constant value here when compare. So we have three types of time constant. One is TP and TT and TG. So turbine time constant, governor time constant, generator time constant. When compared to these three, TP, that is the time constant for generator is more. So already we seen that previous single area system. For the time constant for this one is approximately 20 seconds, and for turbine time constant, governor time constant is approximately 0.4 and 0.5 seconds. So it is completely considered as 0. Now if you take that 0, the entire, so this entire block will be eliminated here. Now we need to get the equation delta f1 of s. Now this is the equation we can get. Here this entire term will become 0. Now we are getting the three factors here, delta pti1 and delta pd1 and this factor, and which is multiplied with this transfer function. So delta f1 of s is equal to kp divided by 1 plus stp1 into, so here so it is the feedback of delta f1 of s, and here you will get minus, so here minus is there, minus delta f1 of s divided by r1 and minus, so it is multiple minus, right, minus delta pd1 and minus delta pti1 of s. So this is the equation we will get from this derivation. Now here this entire box will become 0 because the when compared to the time constant of generator it is very less, so that's why it is approximately equal to 0. Then the block diagram will be comes to the 0 position. Now based on this three parameters and transfer function, we can obtain the equation like this, delta f1 of s is equal to kp and this one. Now if you take that minus common, you will get delta f1 of s is equal to minus kp1 divided by 1 plus st power into delta f1 of s by r1 and remaining thing, and represent it is equation 1, and this equation is represents area 1. Now similarly, how we can write that same equation for area 2? Let me see that. So if you see that same procedure for obtaining that equation from area 2. So here what are the blocks will be eliminated means this entire block will be eliminated because the time constant is very less, and from this delta f of 2 is equals to what you will get, kp2 divided by 1 plus stp2 into the factors delta pt12 and delta pd2 and remaining. So these three factors will get. So let me see what you will get in the equation 2. Right. So this is the equation we can obtain for from area 2. See here, delta f of 2 f2s is equals to kp2 divided by 1 plus stp2, and this transfer function is becomes 0 because tt and tp value should be 0. So finally we will have that 1. Then 1 approach, so it is multiplied with 1, then you will get the same value, and kp2 divided by 1 plus stp2 into, so here the minus delta of s is comes to the feedback to this element, and it is multiplied with 1 by r2, and they will get minus delta f2 of s divided by r2, and here minus delta pdt is adding here minus delta pd2 and remaining. So here already minus is there, minus into minus plus, A12 into delta P2I2. So here A12 is adding with this one. So already we know that A12 is a Thailand factor. So it means that how much, what is the necessary condition to require for when we are adding the two different power stations that was decided by this value, that is Thailand factor. Now from this equation, what we did same thing. So delta F2 of S, let's take that 2 is a common out of the equation. Then you will get delta F2 of S by R2 plus delta. So if now we got the two equations with respect to that area 1 and as well as area 2. Now from the block diagram, the relation between the only Thailand power factor, power, then the equation we can get delta P T1 of S is equals to minus A12 into delta PT. It means, so what is the meaning of this means? So this is the Thailand power getting from the area 1 and this is the Thailand power getting from the area 2. Now if you want to equating these two powers, then it needs some additional factor that was given by minus A12. So it never, without the A12 we can't able to tie up with these two. Why? Because these two having the different parameters and different characteristics and different load demands. So if you want to tie up these two different areas, we need to this minus 17 factor is needed. So by using this factor only, we can equating these two Thailand power. Now, so after the equation 1 and equation 2 we obtained from this block diagram. Now this additional Thailand system we can get that equation is delta Peta. So this is the delta Peta1 of S is equals to, so here it is adding here 2 pi T12 of S into, so delta F1 of S minus delta F2 of S. So ఇక్కడ delta F1 of S అనేది పాజిటివ్ క్యారీ అవుతుంది and delta F2 of S is నెగటివ్ క్యారీ అవుతుంది. So that's why delta P T1 of S is equals to 2 pi T12 of S into delta F1 of S minus delta F2 of S. Suppose if we want to write this value for area 2, what we have to do means we will get that additionally minus A12 here. Okay now, so minus A12 we will get here. And for identical cases, so for identical cases in the sense when the two areas are generating the same amount of power, then your A12 value will be become 1. So already we know that. So for identical case, A12 is equal to PR1 divided by PR2. Now when the two power stations are generating equal power, then you will get the 1, right? So from this equation, when we A12 value will becomes to 1, you will get only minus 1 minus of delta P1. So here A12 is equal to 1 because of it is identical cases. So when it is identical cases, the real power generated by area 1 as well as area 2 should be same. Right. So from equation 1, so we have equation 1, right? This is the equation 1 here. This is the equation 1. From this, what we will do, let's see. So if you observe this equation 1, instead of, so bring that all delta F1 of S in outside. So here delta F1 of S on the other. So we have the two factors delta F1 of S. Now this factor when it comes to this left side, then delta F1 of S is equals to into 1 plus Kp1 divided by 1 plus St power. This is we will get and equals to and minus Kp1 divided by 1 plus St1 into delta Pt1 and delta Pt1. So this is the equation you will get from the equation 1. Right. So this what we are doing here. Just we are arranging that all delta F1 of S as a common factor. Then when brings to the left side, then you will get the like this. And now if you simplify this equation by doing the cross multiplication, r into, so if we take r into 1 r plus s r tp plus kp divided by, and well compared to that, the left hand side and right hand side both denominator factors are same, so we have to we can cancel it each other. The finally delta F1 of S we will get minus kp r divided by SRTP plus KP plus R into this one. Now similarly from equation 2, the same what we did here, just bring that all delta f parameters in single side, and we can take that common, and after that cross multiplication finally we found that delta f1 of s and delta f2 of s. Now the main intention why we are using the delta f1 of s and delta f2 of s means here if you observe this constant parameters, that is kp and tp, the entire frequency load control should be depends on this these two factors. One is kp and another one is tp. So why means why these two parameters was decide this low frequency control means already we know the value of b. B is equals to delta f pd divided by delta f. That is అంటే b అనేది దేని చూపిస్తుంది అంటే ఎంత ఫ్రీక్వెన్సీ చేంజ్ అయితే లోడ్ అనేది చేంజ్ అవుతుంది. ఫర్ వాట్ పర్సెంటేజ్ ఆఫ్ ఫ్రీక్వెన్సీ చేంజెస్ with respect to that what percentage of load. Okay, and already we know that kp is equals to 1 by b. Okay, so it means that when the variation is very less, then the proportional constant, the gain value will be more. Okay, ఎప్పుడైతే వేరియేషన్ అంటే స్మాల్ డిస్టర్బెన్స్ కి స్మాల్ వేరియేషన్ కనుక ఉంటే then we will get that less less value of b. So when the b value is less, then we will get that more gain value. So ఎప్పుడైతే gain value అనేది ఒక ట్రాన్స్ఫర్ ఫంక్షన్ లో ఎక్కువ ఉంటుందో then the system should becomes to be steady state condition. ఓకేనా, సో అందుకని మనకు గెయిన్ ఒక సిస్టమ్ యొక్క పర్ఫార్మెన్స్ అనేది దాని యొక్క గెయిన్ వాల్యూ పైన డిపెండ్ అయి ఉంటుంది. సో హియర్ ద గెయిన్ వాల్యూ ఇస్ called as kp value, that is the gain value of generator, and this value should be depends on this how much of load will be changing with respect to the frequency. So small changes frequency change ఎలా చేంజ్ అవుతుందంటే based on the load variation. So అంటే ఎంత లోడ్ చేంజ్ అయితే ఎంత ఫ్రీక్వెన్సీ చేంజ్ అవుతుందంటే ప్లస్ ఆర్ మైనస్ 5 లేదా మోర్ దాన్ దట్ ఆర్ లెస్ దాన్ దట్ based on that load changes. Okay, that was we can obtain from the kp, and tp we will get 2h divided by f into what is the equation of tp? What is the equation of tp? So here the time constant of generator is given by 2h divided by f into b. So you can observe that this b value will be decides that what is the value of kp and tp, and these two parameters gives that how much of frequency was controlled in a control area, particular area, that is area 1 and area 2. So now we derive that that is output of two power stations. One is delta f1 of s and delta f2 of s. We derived in the form of transfer function. Now by using these two values, let me see that how we can proceed that remaining steps. Right. So substitute delta f1 of s and delta f2 of s in equation 3. So let me see that what is the equation 3 here. Right. So this is the equation 3 we have. Just I am writing in left side. So delta p tie 1 of s equals to 2 pi t12 divided by s and delta f1 of s minus delta f2 of s. So this is the equation, and now in this equation we have to substitute these two values, delta f1 of s, delta f2 of s. Right. So if you substitute these two values, we will get the equation like this. So 2 pi t12 divided by s, and this term is belongs to the delta f1 of s, and this one is delta f2 of s. Now when compared to these two terms, there is a one common factor is there, that is common factor is gain value and time constant. Now from these two terms we have to bring that the common factor, then we will get equation will get like this. So after that, just multiply the two all terms in this equation, that is 2 pi t12 divided by s into minus kp or divided by s or tp plus kp plus or into this one, and remaining plus into t pi and this one. So minus 4 pi t12 kp or divided by s into remaining thing. Okay, now from this equation what we have to do means, while observe these two equations, we have the parameters, that is delta p tie 1. Okay, now, so this is the equation equals to delta p tie 1 of s. Now we have the in this equation we have the two terms of delta p tie 1. Now this equation brings to this left side, then you will get this equation like this: delta p tie 1 of s into 1 plus 4 pi t12 kp r divided by s square r tp plus s into r plus kp. Now, so when compared to this dynamic response for single area and two area means, there we used the partial fraction expansion, but we are not supposed to do this. So what is the reason means? So already we know that values of we are already we found that equation from the block diagram by eliminating that time constant of generator, sorry, time constant of governor and time constant of turbine. So we are not considering, right. So that's why we are not getting that higher order S step. So that's why we are not using that partial fraction here. Now from this equation, finally we found that by taking the delta p tie 1 of s is a common, then we will see that what we will get after this each step. Right. So while simplification this the above equation, we will get that the denominator having the same common factor, that is s into s of tp plus kp plus r. So on both sides we have the two terms, then we should be cancelled to each other. Then finally the entire equation, while simplification in the terms of quadratic equation s square plus s into plus constant, then we will find this equation like this. Now if you substitute we are kp, so if you substitute instead of kp by 1b, so let me see what we will get. So here we have the two terms, one is here kp and kp. So if you substitute kp by 1b, 1 by b, so we'll get 1 by b, and here instead of kp I'm substituting 1 by b here, and b will come to the denominator. So this is the equation. We will get that delta p tie 1 of s. Now we will see that what is the equation for area 2 also, right. See after substitute, so already I told you that the entire system performance and the low frequency control should be completely depends on that the gain constant of generator and time constant of generator. So we can call as gain constant of power system and time constant of power system. Okay, no problem. Whatever we can call it, whatever it may be. Why? Because the power should be comes from generator only, right? So now in previous slide we substitute Kp is equals to 1 by B, but in this step we are going to substitute Tp is equals to 2h divided by Fb. So this unit is second. Now if you substitute this equation in this part, then we will simplify this equation by according to the equation. See 2 pi T12 F naught. So F naught will comes to the numerator and delta PD2 minus delta PD1 and 2h into s square. So remaining all we will get the same thing. So this when comes to the multiplication, you will get reverse f divided by 2h, and we will take that s common, b plus 1 by r, and remain in this. Now the denominator is in the form of s square plus 2 alpha s plus omega square. Now let me tell you that how we can decide that stability condition of the this quadratic equation. So man, already you guys are did in the control system, right? So how we can say that whether the system is steady state or not steady state based on this quadratic equation? Ela kanukochu. How many ways we have? How we can say that the system is stable or unstable based on the quadratic equation?
Roots, based upon roots.
Right. So based on the roots, we based on whether the location of roots are left hand side and right hand side, based on that we can decide that the system is stable or unstable or marginally stable. Now the denominator equation. So this is the equation. I'm going to simplify this equation. Why? Because remaining all we know that why these are under constant values, but we need to simplify this value alone. Why? Because it has the b value and h value. So moment of inertia and changing the load with respect to frequency. So ఇక్కడ ఈ టర్మ్ లో మనకు b value h value ఉంది కాబట్టి we need to consider this equation alone. well compared to this one. Okay, now this equation should be compared with s square plus 2 alpha s plus omega. Now in this equation, the alpha we can write f naught divided by 4h. So generally, so how we can so just I'm equating this equation when compared to these two. Let me see that. So instead of here the value of 2 alpha we can write this one, right? So 2 alpha is equals to f naught divided by 2h and p plus 1 by r. Now I need only alpha value. What will get? This two will comes here. So alpha is equals to f naught divided by 4h into b plus 1 by r. Now this is the alpha value. Now we need to you need to find that omega value. Omega square is equals to 2 pi t1 to f naught h. సో ఇక్కడ వచ్చేసి ఎస్ టర్మ్ ని కాన్స్టెంట్ అని రెండు కన్సిడర్ చేసుకుంటారు. వై బికాస్ బేస్డ్ ఆన్ దిస్ టూ వాల్యూస్ ఆల్సో వీ కెన్ గెట్ ద స్టెబిలిటీ కండిషన్. సో ఇప్పుడు చెప్పండి, యాక్చువల్ గా మనకు ఏ మెథడ్ లో ఈ రెండు పారామీటర్స్ కన్సిడర్ చేసుకుంటారు. మన కంట్రోల్ సిస్టమ్ లో డిఫరెంట్ మెథడ్స్ ఉన్నాయి కదా స్టెబిలిటీ ఫైండ్ అవుట్ చేయడానికి. ఏ మెథడ్ లో కాన్స్టెంట్ వాల్యూని ఎస్ టర్మ్ ని కన్సిడర్ చేసుకుంటారు ఫర్ ఫైండింగ్ ద స్టెబిలిటీ కండిషన్? For finding the stability condition, in which method we are going to choose both constant term and S term?
Root locus.
Right. So in root locus we are considering that both values, that is constant and S term. So then only we can get that graphical representation. So how the root locus are lying. So based on that we will get that stability condition. Now from this equation I am taking that two terms, that is alpha and omega square. Now let me see that after this step what we will get, what we can proceed. Right. See now the entire system. So we call it this, the stability should be depends on that characteristic equation. So here in a transfer function the denominator represents the characteristic equation. When it is equal to 0, based on the roots, based on the location of roots, we can say that stability condition of a particular system. The same thing here also. I am taking the equation like transfer function. In the transfer function, the denominator equation, this odd term is represented as a characteristic equation. Now from this equation, I am going to find that how the roots are lying, and greater than 0 or less than 0. So greater than 0, less than 0 says that location of roots. Okay, now so that thing we are going to find now. Right. See based on the roots, since we got that value of alpha and omega square are positive, therefore the system is stable and damped. Okay, now the ratio of characteristic equation are. So endukante when this two actually manaku equation ela ravalante s minus alpha 1 s minus alpha 2. Okay, now so when the two values are positive, so positive was then we will get that the system is we call as so s is equals to alpha 1 and alpha 2. ఈ విధంగా రూట్స్ అనేవి వస్తే then you will get that then the system should become the stable condition. Okay, now so that is the indication here. Now if you find that roots of the equation, that is s square plus 2 alpha s plus omega square. Now for this equation, if you want to find that roots, then this is the equation we have to use, minus b plus or minus square root of b square minus 4ac divided by 2a. Now from this equation finally we can append like this. Now if you want to find the roots, just we simplify that alpha value what we found in the previous slide and the omega value. So after find this then we substitute here. If you getting this s1 and s2 positive value means then the system becomes stable and it is damped. Okay, now let me see that if you want to if it is want to be stable condition, it should be satisfy the three conditions. What are the three conditions? Let me see that. So we have already time response analysis lo ochindi. So if you want to talking about time response analysis, we need to find that how the time is represented with respect to the time అంటే అండర్ డాంప్డా, క్రిటికల్లీ డాంప్డా, ఓవర్ డాంప్డా. సో దీన్ని బేస్ చేసుకొని మనం దాని యొక్క పర్ఫార్మెన్స్ ని ఫైండ్ అవుట్ చేయొచ్చు. ద సేమ్ థింగ్ we are finding also. So first one is if alpha is equals to omega. So if alpha is equals to omega, what you will get? Here minus value. So the system is critically damped. The roots becomes S12 is equals to minus omega. Okay. So this is the condition for critically damped. General గా critically damped అనేది ఎలా డినోట్ చేస్తాము? Based on the zeta. When critical damped, what is the zeta value?
1, sir.
Right. So when it is equal to 1, then it is called as critical damped. So మీకు I will tell you that conditions. So condition చెప్పండి చూడండి. When zeta value is less than 0, then it is called as undamped. When zeta value is lies between 0 and 1, then it is called underdamped. When zeta is equal to 1, then it is called critically damped. When zeta is greater than 1, it is called what we call when zeta is greater than 1.
Overdamped, sir.
Right, overdamped. Okay now. So ఎప్పుడైనా గుర్తుపెట్టుకోండి, ఏదైనా ఒక సిస్టమ్ వాట్ ఎవర్ సబ్జెక్ట్ ఎలా ఉన్నా కానీ ఇఫ్ యూ వాంట్ టు మేక్ ద అంటే ఒక డివైస్ అనేది విత్ రెస్పెక్ట్ టు టైం అనేది ఎలా పర్ఫార్మెన్స్ చేస్తుంది అని తెలుసుకోవాలంటే వీ నీడ్ టు ప్రొసీడ్ దిస్ టైం రెస్పాన్స్ అనాలిసిస్. ఓకేనా. టైం రెస్పాన్స్ అనాలిసిస్ లో మీకు ఆల్రెడీ ఐ థింక్ యూ గైస్ ఆర్ రిమెంబర్ దట్ గ్రాఫ్, రైట్? సో బేస్డ్ ఆన్ ద గ్రాఫ్ we can get that idea అంటే ఎంత టైం లో సిస్టమ్ అనేది ఒక లెవెల్ కి వచ్చింది. సో బేస్డ్ ఆన్ ద లెవెలింగ్ ఆఫ్ సిస్టమ్ we can find based on the time response అంటే డిలే టైం ఏంది, పీక్ టైమ్, రెస్ట్ టైమ్, సెట్టింగ్ టైమ్, మాక్సిమం ఓవర్షూట్. based on this time values we can get knowledge on అంటే సెట్లింగ్ టైం అంటే ఒక డివైస్ అనేది దాని ప్రాపర్ వే కి వచ్చినట్టు అన్నమాట. ఓకేనా. సో ఇప్పుడు ఆ గ్రాఫ్ బేస్ చేసుకొని బై యూజింగ్ దట్ గ్రాఫ్ we can get knowledge on the particular system అంటే ఆ సిస్టమ్ అనేది సెటిల్ అవ్వడానికి ఎంత టైం పడుతుంది, ఆ రైస్ టైం ఎంత, డిలే టైం ఎంత, పీక్ టైం. సో when the system is completely depends on the time response, we need to be examine these 4 conditions: under damped, over damped, undamped, critically damped. So based on these conditions we can examine that the system is particular so and so steady state condition or dynamic condition or it is not steady. So we can get clarity on this performance, okay, by choosing this all 4 parameters. The same thing here we are considering here. For if the system satisfies these 3 conditions, then we can call as the system is working in a stable condition. Only we first is over. So first one is when alpha is equal to omega, then the system is critically damped. ఓకేనా. సో ఇలాంటి మీకు కండిషన్ అంటే కండిషన్ 1, కండిషన్ 2 అని అడుగుతారు గేట్ ఎగ్జామ్ లో. అంటే దిస్ ఇస్ ద దిస్ టైప్ ఆఫ్ క్వశ్చన్స్ యు మే గెట్ ఫర్ 2 మార్క్స్. ఓకేనా. సో ఫర్ లో ఫ్రీక్వెన్సీ కంట్రోల్ ఫర్ 2 ఏరియా సిస్టమ్ వాట్ ఆర్ ద కండిషన్ 1, కండిషన్ 2 అంటే కండిషన్ 1 ట్రూ నా ఫాల్సా. సో ఆ విధంగా అడుగుతాం అన్నమాట. సో యు నీడ్ యు ఆర్ అవేర్ అబౌట్ what are the conditions for 2 area system also. And second case is if alpha is greater than omega, okay now the system becomes under damped. And so greater than omega ante alpha అనేది greater value ఉంటుంది. okay now so when we will get that greater minus value, so then the value should be lies in between the 0 and 1. so ఇక్కడ ఎప్పుడైతే ఈ విధంగా ఉంటుందో so we are getting the magnitude here. So when you are applying this term, then the zeta value lies between the roots are lies between 1 and 0 and 1. Then the system becomes under damped. Next, when we will get that over damped means when alpha is less than omega, then the system becomes over damped. Then the equation becomes then we will get that complex conjugate roots, that is imaginary roots we will get under the over damped system. సో మీరు ఆల్రెడీ డెరివేషన్ చూసేటప్పుడు ఐడియా వచ్చి ఉంటుంది. సో ఈక్వల్ రూట్స్ ఉన్నప్పుడు ఎలా ఉంటుంది, గ్రేటర్ దాన్ ఉన్నప్పుడు ఎలా ఉంటుంది, లెస్ దాన్ ఉన్నప్పుడు ఎలా వస్తుందో మనకు ఆల్రెడీ కంట్రోల్ సిస్టమ్ లో డెరివేషన్ చేసాం. సో 4 derivations: critical damped, under damped, over damped, undamped. So the same thing we are substituting here when the alpha value is less than omega. Okay, so ఎప్పుడైతే విధంగా అవుతుందో, so the minus value will be more here and it is in the form of minus square, and when comes to the out of the root, we will get that imaginary part minus alpha plus or minus j omega square minus alpha square. Now from this equation we will get minus alpha plus or minus j omega s. Now here alpha is a damping factor and omega d is damped angular frequency, and so this is omega s. Omega d is equal to square root of omega square minus alpha square. So this is the three conditions are how we can find, and based on these three conditions we can examine that how the system performance working. Okay na? So in three conditions based cheskoni particular system anedi ela work avutundo ani man identify cheyachu anamata. The same method we can apply it for the area 2. So intavaraku మనం area 1 మాత్రమే చేసాం. So we found the equation for area 1 alone. So చూడండి ఇక్కడ, so we found just only we found that equation area 1. Okay na? If you want to find that equation with respect to area 2, additionally what you will get means here a12 will come. That is the difference area 1 and area 2. ఎందుకంటే if you want equating that area 1 and area 2, the factor we need to consider that is minus a12 and delta p tie of 2. Okay now, so this is about dynamic response of a two-line power system, two area low frequency control. So in this you just need to so మీరు గుర్తుపెట్టుకోవాల్సిందంటే, first of all we need to form the two equations with respect to the delta f1 and delta f2. First equation 1 equals 2 వస్తుంది. నెక్స్ట్ థర్డ్ ఈక్వేషన్ ఏమొస్తుందంటే delta p tie 1 is equals to 2 pi d12 by s into delta f1 of s minus delta f2 of s. ఇది థర్డ్ ఈక్వేషన్. సో ఈ త్రీ ఈక్వేషన్ కనుక్కున్న తర్వాత from equation 1 and equation 2 we need to find that delta f1 of s and delta f2 of s. After these two equations we need to substitute third equation, then again we will get the same procedure until this equation. So until quadratic equation we will get that in the transfer function. Okay now, so this is about dynamic response of a two area low frequency control. So ఇప్పటి వరకు మనకు 70% ఆఫ్ సిలబస్ ఇస్ ఓవర్ ఫ్రమ్ ద థర్డ్ ఇయర్. 70% అయిపోయింది. నెక్స్ట్ మీకు సేమ్ అంటే ఇక్కడ యాక్చువల్ గా సేమ్ టూ ఏరియా కంట్రోల్ పైన when we use the bias control. So bias control అంటే bypass అన్నమాట. సో bypass అంటే మన షార్ట్ కట్ మెథడ్ లో ఎలా కంట్రోల్ చేయడం, దాన్ని bias controlling అంటారు. So we have remaining three or four topics in that. One is two area low frequency control by bias method. So bias method అంటే ఏంటంటే that is a shortcut method how we can make that low frequency control. Next second one is by using the proportional integral controller how we can control low frequency of the two area system. That is the second topic. And third one is what is the different ways we can control the low frequency. That is primary control method and secondary control method. సో ఇక్కడ ప్రైమరీ కంట్రోల్ మెథడ్ అనేది ఎలా ఉంటుంది, సెకండరీ కంట్రోల్ మెథడ్ అనేది ఎలా ఉంటుంది, అది అక్కడ డిస్కస్ చేసుకుందాం. నెక్స్ట్ ఆఫ్టర్ లో ఫ్రీక్వెన్సీ కంట్రోల్ హౌ వీ కెన్ మేక్ దట్ ఎకనామిక్ డిస్పాచ్. సో ఎకనామిక్ డిస్పాచ్ అంటే సపోజ్ ఈ విధంగా అంటే రెండు డిఫరెంట్ పవర్ సిస్టమ్ ని మనం టైఅప్ చేసాం. టైఅప్ చేసిన తర్వాత ద మెయిన్ కన్సిడరేషన్ ఈస్ హౌ వీ కెన్ మినిమైజ్ ద అమౌంట్, అంటే కాస్ట్ ని ఎలా మినిమైజ్ చేయొచ్చు. దట్ ఈస్ గివెన్ బై ద ఎకనామిక్ డిస్పాచ్ కంట్రోల్. సో ఎకనామిక్ డిస్పాచ్ కంట్రోల్ ఏంటంటే మనకు అవైలబుల్ లో ఉన్న సిస్టమ్స్ ని యూజ్ చేసుకొని తక్కువ రేట్ లో ఎంత పవర్ జనరేట్ చేయొచ్చు వితౌట్ ఎనీ లాసెస్. దట్ గివ్స్ వాట్ ఈస్ ద ఎకనామిక్ డిస్పాచ్ కండిషన్ విత్ రెస్పెక్ట్ టు దట్ పవర్ సిస్టమ్. ఓకేనా. సో ఈ విధంగా మనకు 4 టాపిక్స్ అనేవి బ్యాలెన్స్ ఉంది. సో మాక్సిమం నెక్స్ట్ వీక్ లో మనకు థర్డ్ యూనిట్ అనేది కంప్లీట్ అయిపోతుంది. బట్ ద ఇంటెన్షన్ ఈస్ యూ నీడ్ టు బి ప్రాక్టీస్. మీరు ప్రాక్టీస్ చేస్తేనే ఈ ప్రాబ్లం ఈ డెరివేషన్స్ అనేవి గుర్తుంటాయి. If you are not doing the practice, then simply you won't get remember that derivations. Okay now. సో లాస్ట్ టైం కూడా మీరు ఇలాగే నెగ్లెక్ట్ చేశారు పిఎస్ఏ విషయంలో కూడా, పవర్ సిస్టమ్ అనాలిసిస్. ఓకేనా. సో మీకు ఎగ్జామ్స్ అయితే ఖచ్చితంగా జరుగుతాయని ఆల్రెడీ మీరు యూ గాట్ ద నోటిఫికేషన్ ఇస్తారు. సో ఇప్పుడు ఎప్పుడైతే పవర్ సిస్టమ్ ఒకసారి పవర్ సిస్టమ్ చూస్తే దెన్ విల్ గెట్ క్లారిటీ. అంటే మీరు ఇనింటే ఆ సబ్జెక్ట్ రాయగలుగుతారు. ఇఫ్ యు ఆర్ నాట్ లిసన్ దట్ క్లాస్ యూ కాంట్ ఏబుల్ టు అటెంప్ట్ ద ఎగ్జామ్. ఎందుకంటే ఈ పవర్ సిస్టమ్ సంబంధించిన ప్రతి ఒక్క సబ్జెక్ట్స్ అనేవి వింటేనే మీకు అర్థమవుతుంది. సో యూ కాంట్ ఏబుల్ టు స్టడీ యువర్ ఓన్ ఇట్ సెల్ఫ్. ఓన్ గా చదివితే రాదనమాట. ఓకేనా. సో మాక్సిమం వచ్చేసి ఈ సబ్జెక్ట్ పైన ఎక్కువ కాన్సన్ట్రేట్ చేయండి. అండ్ దిస్ ఈస్ ద మేజర్, అంటే ఈ సబ్జెక్ట్ పైన మీకు ఎక్కువ ఛాన్సెస్ ఉన్నాయి గేట్ ఎగ్జామ్స్ లో అడిగేదానికి. ఓకేనా. అందుకని సో మ్యాథ్స్ ఈ సబ్జెక్ట్ పైన ఎంత అంటే చిన్న చిన్న పాయింట్స్ మీకు గేట్ లో అడిగే ఛాన్స్, అంటే కండిషన్స్ కానీ లేదా కండిషన్స్ ఇన్ ద సెన్స్ అన్కంట్రోల్ కేసు లో ఏది 0 అవుతుంది, ఏది చేంజ్ అవుతుంది, అలాంటి కండిషన్స్ అడుగుతారు. ఓకేనా. తర్వాత వాట్ ఈస్ ద టైం కాన్స్టెంట్ వాల్యూ ఫర్ జనరేటర్, టైం కాన్స్టెంట్ వాల్యూ ఫర్ స్పీడ్ గవర్నర్, టర్బైన్. సో ఈ విధంగా ఎక్కడైతే మీకు కీ పాయింట్స్ లాగా ఉంటాయో ఆ పాయింట్స్ ని బాగా రిప్రజెంట్ చేసుకోండి. ఓకేనా. బాగా నేర్చుకోండి. ఆ పాయింట్స్ మీకు యూజ్ అవుతాయి ఎగ్జామ్ లో. ఓకేనా. రైట్. సో ఓకే గైస్, దిస్ ఈస్ అబౌట్ టుడేస్ క్లాస్ అండ్ యూ హ్యావ్ ద 2 days గ్యాప్. సో ఈ 2 days లో మీరు ప్లాన్ చేసుకోండి, అంటే కరెంట్ సెమిస్టర్ చదవాలా లేదా ప్రీవియస్ సెమిస్టర్ చదవాలని. ఎందుకంటే యూ డోంట్ హ్యావ్ మచ్ టైం. సో మీకు మాక్సిమం ఒక 20 days లో మీకు ఎగ్జామ్స్ ఉండొచ్చు. ఓకేనా. సో ఆ ఎగ్జామ్ కి ఇప్పటి నుంచి ప్రిపేర్ అవ్వండి. ఎందుకంటే 1 day లో చదివే సబ్జెక్ట్స్ కాదు ఇవి. ఓకేనా. 1 day లో చదివితే మీరు సబ్జెక్ట్ పాస్ అవ్వచ్చు లేదా ఫెయిల్ అవ్వచ్చు. సో ఇట్ ఈస్ ట్రయల్ అండ్ ఎర్రర్ మెథడ్. ఓకేనా. సో మీరు ఇప్పటి నుంచి ప్రాక్టీస్ చేసుకుని ఇప్పటి నుంచి ప్లాన్ చేసుకుంటేనే దెన్ యూ విల్ క్లియర్ దట్ ఆల్ సిలబస్ అండ్ సబ్జెక్ట్స్. ఓకేనా. రైట్. ఓకే స్టూడెంట్స్, ఐఎమ్ గోయింగ్ టు ఎండ్ దిస్ క్లాస్ నౌ. థ్యాంక్ యూ.